damped oscillation in LC tuned circuit. Now, inductor and capacitor C is connected as shown in this figure. Now the oscillatory circuit is called LC circuit or tuned circuit, consists of an inductance of the coil L is connected in parallel with the capacitance of the capacitor C. Here the most important point is that both the capacitor and inductors are capable to storing the energy. Capacitor C store the energy in its dielectric field, or you can also say that electric field. Whenever the potential difference exists across the terminal of the capacitor C, while the inductor L store the energy in its magnetic field whenever current passing through this inductor L. First, as shown in this figure 2, the switch S is kept on position P. Now the capacitor B start to charge with from the supply voltage Vs, and current start to flow from plus Vs to upper plate of the capacitor, then lower plate of the capacitor, and then negative terminal of this supply voltage. Now as current start to flow from this capacitor, there will be a potential difference appear or exist across the plate of this capacitor C. Now the protons gets accumulated on the upper plate of the capacitors from the positive terminal of the battery, and the electrons gets accumulated on the lower plate of this capacitor from the negative terminal of the supply voltage Vs. Now as the capacitor is start to charge, and after some time capacitor is fully charged. That means the potential difference across these two plates becomes equal to the supply voltage Vs. That means there is after that there is no charging current passing through this circuit, and we can say that the whatever energy so the capacitor C has some store the energy and it is fully charged. Now next, when the capacitor is fully charged and the switch is moved from P terminal to Q terminal, that means the switch S is kept in position Q. So now due to this, current is start to flow from this inductor L, but the self-induced EMF of the inductance which oppose the flow of electrons. Now due to this the rate of rise of current decreases. Now this capacitor is fully discharged. That time maximum current passing through this inductor L. Now as this capacitor is fully discharged, that means so whatever when the current passing through this inductor L, a magnetic field is set up by this inductor L, which store the energy which is given by the capacitor. So when the capacitor is fully discharged, the electrostatic stored energy gets converted into the magnetic field energy stored by the inductor L. Now when this capacitor is fully discharged, beings the causes the magnetic field which is produced by this inductor L, and that time reverse voltage induced across this inductor L according to the Lenz's law. So now the lower terminal becomes positive and upper terminal becomes negative. Now due to this voltage, capacitor is again charged, but its polarity is reversed because the current passing from plus L terminal to capacitor, then negative terminal of the inductor. So due to this, the lower plate of capacitor becomes positive and upper plate becomes negative. Now as the magnetic field produced by this inductor reduces, which increase in the electricity field produced by this capacitor. So we can say that whatever energy stored in this magnetic field of this inductor gets converted into electrostatic field produced by this capacitor C. Now this capacitor is fully charged, and after some time the whatever the magnetic field produced by this L being collapsed, and now this capacitor is again start to discharge through this inductor L, which produce a magnetic field by this inductor L. But the direction of this magnetic field is reverse, because the current passing through this inductor, it is also reverse, and it is flow from lower plate of the capacitor to the inductor L and the negative terminal of this capacitor. So you can say that whatever energy storage in the dielectric field of the capacitor gets converted into the magnetic field store energy, which is associated with inductor N. As shown in this figure, the magnitude of this voltage is decreased with increasing time. After some time, it will becomes zero. So the whatever the oscillation produced by this circuit, it is also becomes zero. Now this oscillation is also called damped oscillation. So already I told you, after some time the value of current becomes zero. This is happen because the inductor and the energy losses occurs in the inductor and the capacitors. So now when the stored energy is utilized to overcome the only losses, that time the oscillations of this circuit becomes zero. Sustained oscillation. Now, as already we have seen, when we give some energy to this oscillator, it produces oscillation. When the energy conversion from capacitor to inductor and inductor to capacitor, that means the energy transferred from the energy stored in this capacitor in the form of dielectric field gets converted into the magnetic field produced by this inductor. And similarly, whatever energy stored in the magnetic field produced by this inductor is converted or is transferred into the magnetic dielectric field produced by this capacitor. Now this each and every conversion time, there is some energy losses occurs in the inductor and capacitor, which reduce the magnitude of this output voltage. Now if we provide the external energy to the to each and every time is equal to the losses occurs in the inductor and capacitor, that time the value of this output voltage becomes constant, because whatever energy required to overcome these losses, this energy is externally given to this oscillator. Amplifier with positive feedback as oscillator. As shown in this figure, one amplifier whose gain is A, and the positive feedback is provided by this network beta by taking the signal from the output of the amplifier A. So the total gain of this amplifier AF is equal to A divided by 1 minus A beta, where A beta is the loop gain of this amplifier. Now when the input voltage V is applied to the amplifier A, which amplify the signals and provide output voltage AV. So the beta amplifier which amplify the AV signal by beta AV, and this signal is applied to the input of this amplifier A. Now thus as a result, the amplifier A will further amplify the signal of BAV. So now there are three conditions are possible. First, your loop gain, the value of this loop gain is greater than 1. Now in this case, the output voltage, the magnitude of this output voltage is increased with increasing time. Second, the value of loop gain A beta is less than 1. So now in this condition, the magnitude of this output voltage is decreased with increasing time. So here the gain of amplifier AF is equal to A divided by 1 minus A beta. And third condition, the value of loop gain AB is equal to 1. So when we put the value of 1 in this equation, we will get AF is equal to 1 upon 0. That means infinity. So in this case, we get output voltage without applying any inputs. Now the magnitude of the output voltage is same, and it provides sustainable output oscillation. That means the value of this magnitude of the output voltage remains constant. That means this amplifier works as a oscillator. Now the condition A beta is equal to 1 is called Bark-Hussein criterion.